So let's see some examples for balancing chemical equations. So for first example, we have ethanol plus oxygen is going to give us CO2 and water. So first of all, we need to balance it. As you see here, for the left hand side, we have two carbon atoms and we have one carbon atom in right hand side. So if we place 2 as a coefficient here, we balance the carbon atoms. So we have 2 here, 2 carbon atoms and 2 carbon atoms, and it's balanced. Next thing is to balance hydrogen atoms. We have 5 plus 1 here, 6 on the left hand side, and on the right hand side we have 2. So if we place 3 as a coefficient here, on the right hand side we can balance hydrogen as well. So 3 times 2 is going to give us 6, and here we have 5 plus 1 is going to give us 6. So far carbon and hydrogen is balanced. The remaining one is oxygen. Oxygen, here we have 1 plus 2, which is 3, and here we have 4 plus 3, so 7 and 3 here. So if we put 3 here, we can make it 6, so 6 plus 1 is going to give us 7, and on the right hand side we have 7 atoms, so it's balanced. So these are the stoichiometric coefficients. We have 1, 3, 2, 3. So we have 2 carbon atoms, 6 hydrogen atoms, and 7 oxygen atoms on the left hand side, and same thing on the right hand side. Next one, we have this chemical equation. So as we see here, we have chromium. We have 2 here and 2 here, so this one is balanced. We can see nitrogen is 2 here, and we have 2 on the right hand side, so this one is balanced as well. And how about hydrogen? Here we have 8, 4 times 2, 8. On the right hand side we have 2, so if we place 4 here, we can make it 8 and 8. So now the remaining one is oxygen. Let's check that one too. We have 7 plus 3 is going to give us 10, and here we have 4. Sorry, we have 7 here, and here we have 3 plus 4, which is going to give us 7. So 7 here and 7 here. We have 2 nitrogen, 8 hydrogen, 2 chromium, 7 oxygen, and same thing on the product side. Next one is ammonia plus oxygen give us nitric oxide plus water. So first of all, we need to balance hydrogen. So here we have 3, and on the right hand side we have 2. So we place 3 here and 2 there. So 2 NH3 plus O2 give us NO plus 3 H2O. So we have 6 hydrogen atoms on the right hand side and 6 hydrogen atoms on the left hand side. So let's check the nitrogen. Nitrogen here we have 2, and on the right hand side we have 1. So we need to place 2 in front of NO. So now 2 NH3 plus O2 plus 2 NO plus 3 H2O. Now let's see number of oxygen atoms. Here we have 2, and here we have 3, so in total it's going to be 5. So here we have 2, if we place 5 over 2, the whole equation is going to get balanced. So in order to get rid of this fraction, we need to multiply everything by 2. So here we have 4, 5, 4, 6. Balance the following chemical reaction. Glucose C6H12O6 reacts with oxygen gas to produce gaseous carbon dioxide and water vapor. So first of all, we need to balance C atoms. Here we have 6, here we have 1, so we need to place 6 in front of CO2. So then it's get balanced. Next one, we need to do the hydrogen. Hydrogen we have 12, here we have 2, so we need to place 6. So let's check the oxygen. We have 6 oxygen here, and we have 12 oxygen here, is going to be 18. Here we have 6, so here we must have 12. So if we place 6 in front of oxygen, we can balance the whole equation. So now everything is balanced. Next example. Solid iron 3 sulfide reacts with gaseous hydrogen chloride to form solid iron chloride and hydrogen sulfide gas. As you see here, we have this example. So let's start with Fe. So Fe, here we have 2, here we have 1. So we need to place coefficient 2 in front of FeCl3, as you can see here. Next one is S, the sulfur. Here we have 3. On the right hand side we have 1. So if we place 3 in front of H2S, we can balance number of sulfur atoms. So now the rest is gonna be hydrogen and chloride. So let me calculate the amount of hydrogen. We have 1 here, and on the right hand side we have 6. For Cl we have 6 here, and on the left hand side we have 1. So we need to place 6 in front of HCl to balance the equation. Now as you see here, we have 2 Fe in both sides, 3S in both sides, 6H both sides, and 6 chloride again in both sides. Balance the following chemical reaction. Next example, we have carbon disulfide liquid reacts with ammonia gas to produce hydrogen sulfide gas and solid ammonium thiocyanate. Which is NH4SCN. So CS2 plus NH3 is going to give us H2S plus NH4SCN. So let's start with carbon. Carbon, here we have 1, and on the right hand side we have 1. S we have 2, here we have 1 plus 1. So these two are balanced. Let's check the number of nitrogen. Here we have 1, and on the right hand side we have 2. Hydrogen, here we have 4, here we have 2, so 6, and here we have 3. So we need to place 2 in front of ammonia to balance the equation. So as you see here, the whole equation is balanced. Next example. SiO2 plus C is going to give us Si plus SCO, carbon monoxide. So Si is balanced, C is balanced. Here we have 2 oxygen, here we have 1 oxygen. So we need to place 2 in front of CO. After that, we can check this carbon atoms. So carbon atoms, here we have 2 number of atoms, and here we have 1. So we need to put 2 in front of carbon. So now the equation is balanced. Next example, SiCl4 plus Mg is going to give us Si plus MgCl2. So Si and Si are balanced. Cl we have 4 here, and on the right hand side we have 2. So we need to place 2 in front of MgCl2, as you see here. So now you can see the Mg here on the right hand side we have 2, on the left hand side we have 1. So we need to place 2 here to balance the whole thing. Next example, if we have Na2SiF6 plus Na is going to give us Si plus NaF. So see, Si is balanced. F, here we have 6, here we have 1. So we need to place 6 in front of NaF, as you see here. Then we need to see Na, or sodium. Here we have 6, we need to place, and here we have 2. So 6 minus 2, we need to put 4 here. So the whole equation is balanced now.